Alright, so today's topic will actually be on kinetic particle theory. For those of you who have just started Sec 3, you will realize that this is the first topic you will learn in chemistry. And for those of you who are in Sec 4, okay, you will just be a short recap of what you learned in Sec 3. Now, today's session, I will go going very slowly because I believe that some of you are just new to chemistry and you want to actually appreciate the concept. Okay, alright, so let's go down to page number 2 first. Okay, let me start off with kinetic particle theory. Now, in the world of chemistry, we study many different topics. In lower secondary, we learn about sciences, right? So we learn about biology, physics, and chemistry all combined together. And some schools, they even teach you as a combined science kind of module, right? So when we talk about chemistry in particular, we are dealing with the experimental side of things, right? We are looking at how chemicals can actually combine together to make the world, okay, what we call a better place as well. All right, so what is kinetic particle theory all about? Why is it the first topic? Why are we studying this topic for chemistry? Okay, now the term kinetic particle theory, I don't want you to go in and think that, okay, kinetic particle theory is just the name, okay? I don't need to understand this. Now, I want you to appreciate what is the theory behind this chapter. Okay, so as we learned about in lower secondary and in primary school, we learned that all matter, okay, all matter, they have two distinct characteristics, okay? So write down this with me. All matter have two distinct characteristics, okay? Now, what is the two distinct characteristics that matter have, okay? Now, the first characteristic that matter has is that it has mass, which means that if you put it on a weighing scale, it will tell you that it has mass, right? And the second condition for something to be classified as matter would be the fact that matter occupies space. Okay, so this is the two very key ideas that you must grasp over here. This is just a recap from primary school. Okay, so when we talk about this, you must be very careful because what is considered to be matter, okay, it is very important in this chapter. Now, kinetic particle theory, as the name suggests, is talking about the theory or the concept behind particles. Okay, particles, which means all the different molecules, all the different substances, okay, that make up something. And what is the term kinetic mean? Okay, the kinetic basically means movement. Okay, in other words, we are actually learning about the movement of particles in this chapter. Okay, so when we talk about this, you must be very careful because this chapter is the key fundamental before you can progress on to different chemistry chapter. Okay, so I've been teaching many batch of students, okay, and sometimes, right, because students are new to the chapter, they may find it a little bit challenging, but no worries, as we explore together, we will actually get better at this. Okay. Now, I want you to first write down for me what are the three states of matter, okay? A hint is already given over here on the right-hand side. Very simple. Three states of matter. Okay, so the three states of matter are solid, liquid, and gas. These are the three states of matter. And typically, when I teach this chapter, I will always use the example of water because water is the most easy one to illustrate the idea, right? So in solid state, what is water? Water is ice. In liquid state, what is water? Water is just basically liquid water. And in gas, what is the water called? It is either called steam or is called water vapor. Okay. So normally in chemistry, we are not very particular about the name that we use over here, but more so, okay, what is the concept and what is the terms that we are actually writing out. Okay. So for this part over here, I want you to be very careful of this. Let's go down to the next part over here. Now, in this question, we are asked to explain. Okay, so don't be scared by the question, but let's look at this question together. Basically, it's just a starter to the topic itself. Okay, so not for you to write out an answer, but for you to think. Okay. Now, explain how the particles are arranged in a solid, a liquid, and a gas. Okay, And we must describe what is the arrangement, separation, force of attraction, motion, and kinetic energy. Okay, many different terms in this chapter. I want you to always, when you come across a question, slow down and read it slowly. Okay, the key is to read slowly and read carefully. Now, in this question, we are asked to unpack the arrangement of solid, liquid, and gases, and we want to describe what is the arrangement, etc. Right? So firstly, I want to bring you back to your understanding in primary school. Okay, so in primary school, what have we learned? Okay, let me just draw out 3 boxes for you over here. Can you all draw out 3 boxes as well, so that we are able to illustrate our understanding over here? Okay, so sorry, the boxes are not closed. Okay, so assume that these 3 boxes are the same box. Okay, I want you to actually help me to illustrate what is solid, liquid, and gas in these 3 boxes. Okay, so I'm going to put solid, liquid, and gas. Okay, so this is liquid. So in the solid, liquid, and gas, right, what we are looking at is basically the shape of the particles or the behavior of the particles in each of the condition. Now, if I give you an example, I have a bottle of hand sanitizer over here. Okay, you can see this bottle of hand sanitizer over here. Now, the bottle plastic, okay, the bottle plastic, right? Okay, basically the plastic bottle is made from plastic, okay, as mentioned, and it is solid. So solid means, okay, solid means that particles must be very rigid, right? Because when I press it, it doesn't give way, okay? It doesn't give way. So solid means everything must be in a very compact kind of structure, right? So therefore, we will expect solid structure to look something like this. Okay, maybe you want to draw this out. Okay. So solid structure looks something like this. So you can see that everything, all the particles are actually very closely packed in a very orderly manner. Now, I want to show you a live demonstration as well. Okay, so you imagine over here that I have the same bottle of hand sanitizer. Now I give you my hand. I'm going to pour some sanitizer, okay, onto my hand. Now you can see that the sanitizer is actually dispensing out. Now on my hand is the sanitizer. And when I rub my palms together, what happens? We actually have a liquid, right? Okay, sanitizer is a liquid. And you notice that sanitizer is able to actually flow around. Okay, when it flows around, it displays property of liquid. And that means that, is it in a regular arrangement? When it can flow around, it isn't. Okay, it is in a very disorderly arrangement. And that is how we actually get the liquid structure, which looks something like this. Basically, it is just random particles that are actually put together. Okay, with no order whatsoever. It is just random shape. Okay, so you can notice that, okay, the spacing between the particles are actually comparable between solid and liquid. They are all quite close together. Now, the difference comes when we are talking about gases. Okay, when we are talking about gases, the difference is that gases, right, for the particles, they are very far apart. Now, let me illustrate to you with a drawing. So you can see over here that in the solid, we have so many particles, right? In a liquid, in this same amount of space, we have so many particles. But in a gas, maybe we only have 3, or maybe we only have 4 particles. 4 particles of gas. Why is that so? Now, gases, right, are very, very far apart. Okay, the molecules are very far apart. And this is because, okay, for gases to move around, okay, they are actually very fast moving. And why is this so? It's because of how gases, when they actually exist, right? When they actually exist, you'll realize that, okay, the spacing between each molecule are actually very far. When it's close together, it is going to become liquid, right? So when it's far apart, it is gas. So this is the first understanding we must have when we talk about the chapter on kinetic particles. Okay, so if we understand this, we can move on to something a little bit more challenging, which is to attempt a table style of consolidating our learning under this section. Okay, So if you're all good with this, okay, let's move down to the next part. Okay, so I want you to over here, right? Okay, can you draw me a table? Okay, just draw something like this. Okay, yeah, just draw something like this. Now, in this table, I want you to be very, very detailed. Okay, so I will be very detailed with you. Okay, I make sure you copy down whatever that I tell you to do. Okay, so we are dealing with what? We are dealing with solids, liquids, and gas. These are the three things that we are dealing with in this chapter, right? So remember, solid, liquid, gas. These are the three states of matter, nothing else, only three states. Okay, so if you have any question, once again, you can type it into the chat so that I can actually look at it, or you can unmute if you're not shy, you can unmute and ask your questions directly. Okay, now I have invented this particular framework for you to actually do this question in a very fast way. So sometimes students in the exam, right, last minute, they cannot think. And you must follow this framework. Everything, okay, all your problems will be settled. Now, this framework is called the MKFD framework. Okay, listen carefully. It's called the MKFD framework. Now, I'm going to explain step by step to you what this framework is, okay? So if you find it useful, you can use it. If not, then you can actually use your own method as well, okay? So I'm not trying to force you to use it, but I'm just giving you an alternative. When you want to answer questions, you can actually consider this kind of framework so that you don't miss anything out. Okay, first things first, M. What does M stand for? It stands for motion, okay? Or sometimes we call it movement. So when we talk about motion, we are talking about how fast the particles are moving, okay? So can anyone tell me, right, okay, for gases, now gases, since they are in the air, okay, they are actually very fast moving, am I right? However, if I compare it to solid on the other hand, the particles, you are reminded, okay, that it is in such a small confined space, they actually vibrate about the fixed position. Okay, so you realize that, okay, I have one particle over here. When it's moving, they doesn't travel here and there. They are just going to vibrate about the fixed positions. Okay, so they are just moving left and right, up and down, circular in the very confined space with another particle next to it. Okay, so in the motion part, we are going to write that it has slow motion, means the speed is very slow. Now, on the other hand, liquids, okay, as demonstrated just now by the hand sanitizer experiment, we realize that liquids are very fast, okay? Do you agree with me? Liquids are very fast, right? So I'll just say that they are fast moving. What about gases? The gas, okay, they actually move very fast throughout the atmosphere. So I'm going to put here very fast. Okay, so it is slow, medium, and fast, right? Okay, so it's a slow, fast, and very fast speed. Now, then after that, let's talk about K. Now, what is K? K stands for kinetic energy. Now, what is kinetic energy? Sometimes students will get confused. What is kinetic energy? I learned so many energy in my lower secondary, but I cannot remember any of it, right? So kinetic energy, once again, I remind you, kinetic stands for what? Movement, right? Kinetic stands for movement. So energy that is associated with the movement of something. Now, every year, I like to give my student this example, right? So if you are very sad and very down or very tired, okay, will you be walking very fast or will you be walking very slowly? Normally, right, okay, if you are feeling very down, if you're feeling very tired, you will take a slow walk, am I right? Okay, so you just walk slowly to your destination. However, if let's say you are actually very excited, you are very happy, and you are in a good mood, then do you think that you'll be walking fast, you'll be jumping around, hopping around, okay? Now, this is exactly what we're talking about when we're talking about kinetic energy, right? So basically, when we are moving slowly, we are low in energy. Okay, so low in energy, because we move slowly, that's why we low in energy. If you got high energy, of course, we move very fast already, right? Because we want to burn off the energy, am I right? So you can see over here that kinetic energy is low for solid, because solid, they only move about the fixed position. They vibrate about the fixed position. Now, liquid, okay, you notice that they are actually in this irregular arrangement. They can slide past one another easily. So you can see over here, okay, maybe this one will go here. Maybe this particle will go here. This particle will go here, etc., etc. Okay, so they can slide over one another. Okay, so this one is high. What about gases? Now, gases I want to show you, okay? Gases, you see closely, this particle, okay, this particle can go here. This particle can go here. This particle can go here. It is not bumping into anything, right? They can move as fast as they want. They are very high in energy. So I'm going to put here, very high in energy. Okay? Now, what about F over here? This stands for force of attraction. Now, when students learn this for the first time, they are very confused oftentimes, okay? They are very confused by this. Why is that so? Now, because they think that force of attraction, right, refers to whether or not something is attracting something else from a far away distance. Okay, I'm telling you that is not the correct concept. What is the term force of attraction trying to tell you? Now, if I have two weak magnets, okay, I give you the example. I have one magnet here. I have one magnet here. If these two are very weak magnets, would they choose to come very close together, or would they choose to stay apart? Okay, if I have two weak magnets, then they attract a bit, they attract a bit. The attractive force is very low. Do you agree with me? Now, if I increase the strength of this magnet, okay, look at this. I increase the strength of this magnet. I increase the strength of this magnet. Okay. Now, this magnet very strong, this magnet also very strong. Now, when I put them together, do you think that the force of attraction is very strong? Because they are both very strong, right? So they pull each other very strong, right? And they will come very close together with each other. Now, this is exactly the idea that I want you to learn over here. When the things are very close together, this means that the force that is holding it together is very strong. On the other hand, if you have particles that are very far apart, this means that the force of attraction is lower, is much lower. Okay, to give you this example, much lower, because they don't like to come together. The attractive force not a lot, right? Because you see, this one come here, or they attract a bit. Okay, this one gonna bounce away. If this one come here, okay, they attract a bit, then it bounces away. They never ever be very close together. This is not allowed. Okay, so my point to you is, since you see that the distance is very close together, this means that they are attracting each other very strong. And therefore, in solids, the force of attraction is very, very strong. The force of attraction is liquid. In liquid is quite strong. Okay, I just put here quite strong. Okay, and in gases is very weak. Okay. Now, the last one is the one that students sometimes forget to write. Now, D stand for distance. Okay, sometimes we also say stand for disorder. Now, what does this word mean? Now, disorder simply means how messy something is. Okay, how messy something is. So you can see over here that, okay, solid, very nice. Neat rows, okay, neat rows, neat rows. Very nice, nicely arranged. So what is the distance and disorder? They are very closely packed. Okay, this is the keyword, closely packed. And also, okay, they are very orderly. Okay, very orderly. So keyword is closely packed and orderly. For liquid, on the other hand, let's look back at the diagram. This one over here show you that, okay, it is still closely packed, right? Because you see, they are still very close together, right? But they are no longer in the orderly. They are very messy now. Okay, so I'm going to say that this is closely packed. Okay, and disorderly. Okay, do not ever use messy in the arrangement because messy can be represented in different form, right? So disorderly just tells me that the arrangement is very messy. And last but not least, for gases, right? Gases, as you can tell, they are not closely packed. They are very far apart. Okay, they are very far apart. And since they are far apart, this means that their arrangement definitely is going to be disorderly. Okay, so far? So you can see that I've actually summarized all you need to know for solid, liquid, gas into a table represented by MKFD. Okay, so in your first WA or your first weighted assessment, first term test, okay, different school call it different names, you can actually utilize this framework if they ask you questions about describing the kinetic particle theory. Okay, so if you're all good with this, then let's look at the next page. Now, in this part over here, we are looking at the theory, the kinetic theory of matter. In other words, we are looking at the scientists' assumptions. Okay, we are talking about the assumptions that scientists actually made when talking about the theory or the concept that they are looking at or they are investigating. Right, so they have actually found out that particles are too small to be seen directly. Another word for this would be microscopic. Okay, and if you come across the word called particulate, L-A-T-E, particulate, this also means very small. Okay, so particulate, we are talking about one particle itself. Now, the second assumption that they made was that there are spaces between particles of matter, right? So between particles of matter, between different particles, there is actually space, right? As mentioned over here in our drawing just now, okay, so I'm going to just do a rough drawing for you again. So if I have a solid, now you realize that there are actually empty space in between the particles as well. Now, the last one is the one that commonly students don't know. This one is the one that students commonly don't know. Now, what is the third assumption is that the particles are in constant motion. They move at different speed in different state. Now, student will ask me, Cher, solid particle in constant motion, are they in constant motion? I thought they are just in a fixed position. They are not moving, what? Okay, you must understand this from the correct perspective. Now, solids, right? Okay, they are not moving across one another. What they are doing is that they are vibrating or they are moving about the same position. Okay, so they are vibrating. This one is for solid only. About the same position. Okay, you must be very clear on this. Vibrating about the same position. Okay, now if they vibrate about the same position, this means that they are still moving, but they are moving very slowly. Right, agree with me, because they have one position, then they just vibrate slowly. Okay. All right. Okay, so this part over here is something that you want to be very careful about. When people tell you something is in constant motion, then you must tell them that they are moving, okay? They are moving. Don't tell them that they are in a fixed position. Okay? All right. Now, let's go down to the next part, which is on the particulate model of matter. Okay? Now, this part, right, is talking about the property, okay, property of solid, liquid, and gas. So we are no longer talking about solid, liquid, and gas by itself. We are now looking at what is the important detail of their so-called personality, right? So when you look at somebody has their name. We are no longer looking at their name. We are no longer looking at their physical appearance. We are now finding out more about what they are, okay? What is their personality and what is the resultant results, okay, or consequence that we actually attain. Now, particulate model of matter, okay, so we got solid, liquid, and gas over here. Once again, I'm going to run through this with you. Now, for solids, they are closely packed in orderly arrangement. They have very strong force of attraction and little empty space. Okay, so for solids, closely packed, force of attraction is strong, little empty space. Now, for liquid, they are closely packed, but in a disorderly manner, right? So they are not in orderly manner, they're not in regular arrangement, but they are in disorderly manner. They also have strong force of attraction, but not as strong as solid, okay? And space as well. Now, gas particles, they are far apart, weak force of attraction, and in a random arrangement, okay? So no orderly arrangement, So notice over here, we are always talking about what is the motion and what is the distance or disorder. Now, what does all this arrangement stuff, right, lead us to? It actually has an impact of what solids, liquid, and gases behave or how they behave. Now, you imagine for me, I'm going to just draw this in for you again. If you want to draw this, it may be good, but if not, it's fine as well. Just listen to me. Now, for solids, because of the fact that they are in this regular arrangement, this means that they are actually very closely packed already, right? This means they have a fixed volume. Okay, cannot change the amount of space it occupies. And it is not compressible. Now, what does not compressible means? I cannot squeeze, okay? I cannot squeeze to fill a smaller space. Basically, we are talking about the volume. Now, what about high density? Okay, high density means that in one unit area, okay, in one unit area, I have many particles, okay? Agree with me, many particles. And this means that they are actually, once again, very closely packed and they have high density. Now, next we look at liquids. Okay, so for liquids, it's a little bit different. Okay, so for liquids, you must be very clear. Liquids have a fixed volume. They are not compressible, but high density. Now, you tell me, these two are exactly the same. But what is the difference? Solid, they cannot flow. Do you agree with me? They cannot flow, right? Because it's a solid, it doesn't flow. Liquid, on the other hand, it can flow. So this is another physical property that comes about because of the difference in the force of attraction. So if the force is very strong, everything is bound together tightly. Do you think they can flow together? They can flow to over one another? No, right? Not possible. But if the force is a little bit weaker, so you can see that the particle can actually move across one another. And that is the reason why liquid can flow. Now for gas, I don't want to talk so much about it. No fixed volume, it is compressible, low density. Okay, because there are many particles but far apart, I can squeeze them together. Okay. Now, motion of particle and resultant physical property. Okay, so this one is all what I've said just now, which is all over here: kinetic energy, and kinetic energy. What is its movement? Slide past one another for liquid, but not move freely for solid. So for air you can, for gases, it can move anywhere in the container. So what is the resultant physical property? Fixed shape for solids, no fixed shape for liquid and gases. Okay, this one is quite common sense because you talk about water and air, right? Okay, they don't have fixed shape, but for ice, there is actually a fixed shape. Okay, so this one is just for your consolidation purpose, for you as a summary table when they're asking you, oh, what is one of the physical properties of solid, liquid, and gas? And you can tell me what's the difference as well. Okay, let's go on to the next page already. So if you still need to annotate anything or copy down, I'm going to leave this here for another 30 seconds or so. So if you're fast, you can go on to the next page and look at the practice question that I've included for you. Okay, so if you're all good with this, let's go on to the next page. And this particular page is something that I want you to take very close attention to, because this question is something that tests your understanding of the whole chapter. Now, in this diagram, right, we are given particles of pentane at atmospheric pressure, but two different temperatures. Okay, so we are looking at something, okay, a substance. This is matter, okay, this matter. Now, something that occupies space at two different temperatures. Now, we are looking at this thing called the melting and boiling point, okay? Melting at minus 130 and boils at 26 degrees Celsius. Now, what could be the values for X and Y? So containers X and containers Y. So I want you to take a moment to actually ponder about this question. Write down something, okay? And I'm going to go through this in just a short while. I'm going to also teach you another skill for students who have trouble visualizing melting point, boiling point, etc. Okay? All right. Let's look at this question. Now, they have given to you that the melting point is negative 130 and the boiling point is 26 degrees Celsius. Now, I want my students to be able to confidently tell me what state is this and what state is this. Okay, these two are this one and this one. So you can first be able to identify that this one is a gas, because you see that particles are far apart. Immediately you can tell me that this is a gas. On the right hand side, this one is definitely going to be liquid, right? Because the particles are close together. Okay, they are close together, but they are in disorderly arrangement. Okay, so they are in disorderly arrangement, yeah? Okay, so we have gas and liquid over here. Very good. Thank you, Andy. I saw your response to the chat as well. So you can see over here that gas and liquid. Now, what is the melting point and boiling point supposed to do over here? I want my students to learn this technique. Always use this technique. It's called the SLG technique. Okay, so let's draw a straight line over here. I put S, L, G. Now, then I put two lines in between S, L, and G. Okay? I will write down the melting point on the left line and the boiling point on the right line. I will explain to you why I do so. Okay, so once I have done this already, what I want you to do is to follow me closely. S stands for solid state, L stands for liquid state, and G stands for gaseous state. So in the solid state, okay, when I'm going from solid to liquid, I must melt, right? So the melting point is 130 negative. Liquid to gas is a boiling process, liquid to gas, right? Is at 26 degrees Celsius. This is the boiling point. This is the melting point. What this means is that everything, okay, look at this closely. I have a negative 130 over here. Whatever to the left of negative 130, it will be a solid. And whatever to the right of 130, it will be a liquid. For 26, whatever to the left of 26 degrees Celsius, it will be a liquid. And whatever to the right of 26 degrees Celsius is going to be a gas. So using this technique, right, every question can be solved. Because when you get given a temperature, if I tell you, okay, 13 degrees Celsius, can you tell me what state is this particular substance at? So you see 13 degrees Celsius, you just slot in. Is it fall within this range? Is below 26 and above negative 130? Yes, right? So it's going to be liquid state. Okay, so using this idea, I want you to try and get the answer for this question. It should not be very difficult. Now, I got solid and liquid and gas. Now, negative 130. If I go negative 135, this means that it is to the left of negative 130. This means that it's going to be solid. But this one over here shows us that it's a liquid, right? So my temperature must be above negative 130, which means that it has to be a negative 120, 110, or 100 negative. All right. So try again. I think the answer should be 1. Okay, how do we verify? Let's start in the temperature. X is 30 degrees Celsius. Is supposed to be gas, right? So I start in 30 degrees Celsius. Correct, right? Because it's supposed to be gas. Now, Y is negative 100. So I got 26 over here. Okay, I count, negative, negative. This is negative 100 degrees Celsius. Therefore, okay, this one is liquid. This one is gas. Correct. So option 1 is correct. Okay. Now, for you, those of you who choose option number 4, right? Okay, so 70 and 135. Okay, 70 I start in. Correct. But negative 135, this one negative 130. Go down further. Negative 135. Even colder. Then it's here. So is it a solid? No, it's not. So this one over here, okay, it's not correct. All right. So option 1, okay, should be the correct answer for this question. Okay, any question? Okay, if no question, then I'm going to move on to the next page, right? Okay, so now the next page is talking about changes of state. Now, I want you to try out this one first before I say anything. I want you to try out this one first. Should be quite simple. Okay. Try out this table over here. Okay, let's look at this one. Now, for solid, right? Okay, there are only 2 possibilities. One is to go to liquid, then go to gas, or the other one is to directly go to gas, right? Okay, so solid got 2 possibilities. One arrow is direct to gas, no liquid. Okay, no liquid. The other method is solid to liquid, then liquid to gas. This one is the second method. So let's talk about the conventional one first. Solid, liquid, then gas. Okay. So solid to liquid is very simple. Solid to liquid, we call it melting. Okay. So imagine your ice, it melt to form water. This is called melting. Okay. So from liquid to gas, on the other hand, liquid to gas, what is it called? It is called boiling, or it is called evaporation. Okay, so 2 names for it. Then we will explore the difference between these 2, okay? Now, what about solid going to gas directly? Okay, what about solid going to gas directly? This process, sometimes people don't know, is called sublime. Okay, this word you must know, must learn. It's called sublime or sublimation. Now, what it's talking about basically is a solid going to a gas without becoming a liquid first. Okay, without becoming a liquid first. So you imagine solid, I just heat it, then suddenly the gas come out. Okay, it doesn't become liquid, it doesn't melt. Now, let's look at the reverse process. Now, gas becomes solid. Okay, gas becomes solid through the process of this process. Okay, liquid first, then becomes solid. So gas to liquid is called what? Gas to liquid. Remember, if you have boiling water and then after that, you open the top, you realize that the cover of the kettle have some condensation, right? So this is called condensation. Now, from liquid to solid, very simple. It's called freezing, right? So I put the water into the freezer, then it becomes solid ice. Can Okay, so this one should be quite simple, no problems one. Now, let's look at the next part, which is on the temperature increasing, okay? But before we do this part, I want to check in with all of you whether or not you are still following. If you are following, can you give me a thumbs up so I know? Okay, Okay, I see. Thank you, Angie, for your thumbs up as well. Okay, I see it now. Okay. Okay, lah, should be okay, right? All should be okay. Okay, let's talk about the next part on temperature increasing. Now, as temperature increases, we are talking about different process that will happen. I want to bring you through. I want you to outline all the process that will happen as temperature increase. Let's start from solid. Okay, I want you to outline this process with me. Now, first you write down solid over here. Center box, you write down liquid. Third box, you write down gas. So I want you to go in this direction, okay? This direction, left to right, as temperature increases. Okay, solid, liquid to gas. Now, from solid to liquid, okay? From solid to liquid, what is the process called? It is called melting, am I right? And from liquid to gas is called boiling, am I right? Okay, so boiling. Now, I want to give you the detail of what to write in the exam when you are given this kind of question. Now, in the solid state, okay, imagine I have ice. I start to heat the ice. Maybe I put it on top of a Bunsen burner. Okay, so I put it on top of a Bunsen burner. I try to heat the ice. Now, what happens? Do you agree with me that when it gets heated, the molecule become more energetic? The water molecule, the water particles inside the ice becomes more energetic. They move faster. Okay, so you must tell me that the particles, they gain kinetic energy. And what happens? They vibrate faster. Okay, vibrate where? Vibrate about their fixed position. Remember, it is in a solid arrangement, regular arrangement, about their fixed position. Okay, so when I heat it, gains energy, vibrate faster about the fixed position. Now, what happens next? What happens when the temperature gets high enough? What happens when the temperature gets high enough? Now, what happens is that melting occur, right? So, okay, you can see that the vibration increase. Then, okay, the force of attraction okay, between particles are overcome. What does this mean? Now, if I had the force of attraction first, they are close together. When I hit it, then the force becomes less and less. My particles will start to separate from one another. Next, in the liquid state, what happens? Particles are free to move about. And slide across one another. Okay, so this is what happens in the liquid state. Now, boiling, what happens? Boiling, once again, you're going to write this same thing over here. Force of attraction between particles are overcome. Now, instead of telling me solid particles, just replace the word with liquid particles. Easy, right? And last but not least, for gases, you will tell me that particles are going to move freely at high speed. This is very important because you must be able to display to me the characteristic of a gas, which is where the particles actually move at high speed. Okay, so if you're all good with this, okay, let's try the next question together. Okay, I'm going to move down. Next question. Okay, I want you to cross out this question. Question number 2, just cross out. Let's look at question number 3. Question number 2, not important. Now, question number 3 is on a table showing the melting and boiling points of 4 different substances. Which one is likely to be a liquid at room temperature and rapidly evaporate off at room temperature? Okay, so what is the condition for rapidly evaporate off? Now, there's a special term for this. It is known as volatile. Now, what is the term volatile means? It basically means that this particular substance has a boiling point just slightly higher than room temperature. Okay, I'm going to write this down for you. The boiling point of substance is slightly higher than room temperature. Now, once we understand this, this means that, okay, the item or the substance evaporate off very quickly, right? So which is the substance? Very simple. Let's just look at this. Likely to be a liquid at room temperature. So I'm going to draw my table, draw my line again. I have SLG, okay, my SLG number line. So melting point, this is a melting point. Boiling point is here. Okay, so which is likely to be a liquid at room temperature? Room temperature, normally we will take it to be 25 degrees Celsius. Okay, everybody must take note of this. Room temperature always to be known as 25 degrees Celsius. Okay, so something that likely to be a liquid at room temperature and rapidly evaporate off. If we look at the answers options, we will actually narrow down our option to either this or this, right? But of course, this one we will not consider because I want my boiling point to be close to 25 degrees Celsius. That's a dead giveaway. Therefore, option A is the correct answer. Melting point is negative 15 degrees Celsius. This boiling point is 45 degrees Celsius. Therefore, at 25 degrees Celsius, it is indeed a liquid. Okay? Should be okay, right? For question number 3. Okay, now let's go now. Okay, if you are done with question number 3, let's go down now to page number 7. Now, in page number 7, we are looking at this particular concept, which is known as the heating curve. Okay, the heating curve. What is this heating curve over here? Now, heating curve is something that is a little bit confusing to some of you at the first place, okay, in the start, because you don't really understand what exactly, okay, does a heating curve consist of, what is the different part of the heating curve. Sometimes if they give you the heating curve without any readings, or they give you a graph, you must be able to identify that it is a heating curve. Now, what does this heating curve mean? It just shows you as temperature increases, agree with me, as temperature increases, heating, okay, there is a point where we plot a graph that is going to follow a conventional shape like this. Okay, so it will always follow the shape like this, always follow the shape like this. Now, I want to use the MKFD framework again. Okay, remember MKFD framework to actually help us to deduce what is happening at each point on the heating curve. Remember, M stands for motion of particle. K stands for kinetic energy. F stands for force of attraction. And D stands for distance and disorder. Okay, distance and disorder. Now, what I want you to do, very simple over here, is for you to help me label out what is the point on the curve. So we got A, B, C, D, E, and F. Sorry about that. Now, I want you to actually help me to write down this here. Okay, AB, BC, CD, DE, and E to F. Now, in this different part over here, you must pay close attention. Now, I'm going to color code this for you. From A to B, C to D, and E to F, okay, your job will be to help me describe what is the arrangement and movement of particle. Then, right, from this part over here, B to C and D to E, okay, I'm going to color code this again for you. Your job over here is to help me deduce MKFD. Okay, so when you write this down, okay, you tell me, okay, D increase means the distance between the particle increase. Or F stand for what? F stand for force of attraction. Oh, the force of attraction decrease from B to C. Decrease. Or kinetic energy. Okay, kinetic energy increase. That put like increase. Motion. Okay, motion decrease. That put like that. Okay, so I want you to follow this framework for B to C and D to E. A, B, C, D, E, F. This one, I want you to just follow arrangement and movement described to me in words. Okay, I let you try this for a while. So if you're unsure, okay, please let me know so I can actually go through again with you. All right, if you're all good, can you look up for a moment? Let me just go through A, B, C, D, and E to F first. So these are just the different states, right? So you can see over here that in A to B, right, we are talking about something that is solid, purely solid. Okay. Now remember just now I showed you the number line with the SLG. Basically, the SLG has been transformed into a vertical SLG. So I'm going to extrapolate the lines here. This is called SLG. Do you notice over here? Solid, liquid, and gas. So these are the SLG. This is the melting point. This is the boiling point. So I'm looking at it as the temperature increases. So below the L, S is here, right? So in solid state, what happens is that they are actually closely packed. Arrangement is orderly. They have slow moving particles, which means that the kinetic energy is very low. All right. Let me settle the parts whereby it is just between the S, L, and G first. The different transition parts. Okay, I'm going to settle it later. Now, from C to D, we are looking at a liquid. Okay, C to D, we are looking at liquid. Now, liquid is closely packed, but they are in disorderly arrangement, and they have high kinetic energy. Okay, because they slide over one another, right? So they have high kinetic energy to be able to slide over one another. Now, E to F is gas. Gases are far apart, disorderly, and the kinetic energy is super high, right? Because the gas particles are moving very quickly. Okay? And from B to C and D to E, this one is the part that sometimes students will be a little bit confused, a little bit unsure. Let's do it together. Now, from B to C, right, what happens basically is that the solid becomes a liquid. So I'm looking at the difference between this part over here and this part over here. What is the change? Okay. So what about motion? Motion. Did the motion increase or decrease? Of course, the motion increase, right? Because solid, they only vibrate at fixed position, but liquid, they slide over one another. So motion increase. What about kinetic energy? Motion increase means they move faster, right? Move faster means higher energy, am I right? So therefore, energy also increase. Now, what about force of attraction? Before this, they are very close together. They are very close together. Now, then after that, what happened? They are now further apart, right? Because just now close together, now they're further apart because liquid state, they can start over one another once again. This means that the force of attraction is decreased, okay? Because they're now further apart, they are less attracted to each one another. Okay, I have a question over here. Now, is kinetic and motion not the same? Okay, now, kinetic energy refer to the energy that the particle possesses, whilst the motion refer to the movement and whether or not they are moving in a manner that is orderly, disorderly. And also, okay, the kinetic energy just refer to the specific energies of the particles, whilst the movement or the motion refer to which direction, okay, the particle travel. And it is just now we have ascertained that, okay, if they're in a fixed position, they don't move. They just vibrate about the fixed position, move left and right, a little bit up, down. They don't change their position. Whilst in liquid, okay, remember, liquid can slide over one another. This means that there is a direction of motion, right? So therefore, that is what it's talking about. Increase in motion means I'm traveling from one place to another. Whilst kinetic energy simply tells us what is the speed, okay? Just now, vibrate slowly, speed is low, okay? Kinetic energy is low. But now I can slide over one another, okay, I can go like that. This means that kinetic energy has increased. I'm now traveling faster. Now, last but not least, we talk about distance. Distance between the particle, of course, increase, right? Because the particles are now less closely held together. Particles increase itself. Okay. Now, similar idea, okay, is going to be the same answer for this one as well. So if you haven't figured out, you can go back and take a look. It is going to be the same as well. Okay, so this is talking about the increase in temperature. Decrease in temperature, okay, haven't talked about it yet, but okay, due to time constraint, I will not be talking about it. You can actually go home and take a look. So for example, from F to E, what happened? Motion decrease, right? Because they are becoming liquid. Kinetic energy decrease because the speed is becoming slower. Force increase because the particles are coming together, etc. All right, so page number 7 should be okay for you. If you have any question as well, you can let me know as well. All right, okay. If you are good, let's look at the question on page 8. Now, page 8, I want you to attempt this question. Okay, this is a heating curve for a pure substance recorded at room temperature and pressure. We are asked to find out what is the melting point of the substance. Very simple. What can we do? Remember always, we got solid, liquid, and gas, our SLG. Draw a line, draw it out. Okay, so sorry, I don't have a ruler over here. If you have a ruler, okay, that would be best. Draw the line out. Draw this straight vertical line with the arrow, and you put in SLG. Okay, remember the line is like that. I turn it up, so S should be at the bottom, G should be at the top. Now, once we have this in mind, then you must be able to tell me what is the melting point. Melting point is between what? Liquid and solid, am I right? So I'm going to be paying attention to this part over here. Okay, so with this, I can very easily count. I have 1, 2, 3, 4, 5, 6, 7, 8. This has a melting point of 80 degrees Celsius. Okay, so you notice something, I don't really care about the minutes. When I'm looking at a specific temperature value, I don't care about the minutes. Okay, I only care about the SLG. You see, that's why I extrapolate the lines into different vertical segments. Now, in part B, what happens to the temperature of the substance as it changes its state? Now, do you realize over here that this part over here is flat? It's not increasing, right? So it is actually unchanged. Okay, now I'm going to explain to you this particular concept, okay, in future. But for now, you just take it that it is unchanged because energies are actually being used okay, to overcome the attractive forces. Okay, so let's explore this concept in the future lessons as well. Now, in part C, explain why the substance cannot be water. Okay, now you can see over here that the melting point is 80 degrees Celsius. Does water have a melting point of 80? No, right? Because water melting point, remember, is 0 degrees Celsius. And the boiling point of pure water is 100 degrees Celsius. Okay? So you can just say that the melting point does not match. Okay, so do spell it out because I'm just trying to save time, okay, by writing the short forms. Okay, so this is how you actually attempt this question. It's not too difficult, okay? Especially for this set of questions, I've just included some of the basic questions so that you are able to get a grasp of the concept first. Okay, if you're all okay with this, then let's move down to page number 9. Now, page number 9 is something that is very important, okay? Page number 9 is very important. This is probably going to be the biggest takeaway of your lesson today. If you didn't take away anything else, this part over here, pay close attention. What is the difference, common exam question now, what is the difference between evaporation and boiling? What is the difference? Now, let me tell you first that evaporation is basically the same process as boiling, but it happens at different conditions. Okay? So what do I mean by this? Evaporation is going from what? Evaporation is going from liquid to gas, right? Agree with me? Going from liquid to gas. Boiling also, right? Remember water, boil to form water vapor, right? So boiling is also liquid to gas. That's why I tell you it's the same process, but under different condition. Now, evaporation is a process that occurs without boiling, which means that there is no bubbling. There is no you remember when you boil your water, there are bubbles. Okay, there's a very distinct agitation of the solution. Evaporation occurs slowly. Okay, and it occurs at any temperature below the boiling point. This is what you must start. The next one is also very important. Evaporation only occurs on the surface of the liquid. Okay. What about boiling? Boiling occurs rapidly, very fast process. Okay, very fast, will just boil away. It occurs at one specific temperature, which is boiling point. Okay, one temperature. This is all temperature. And it occurs throughout the liquid. Boiling occurs throughout the liquid. Okay, so this is very important. These are the two key ideas you must include if the exam question asks you. Okay, now, next, evaporation and boiling. What is evaporation? Imagine I have a puddle of water over here. I have a puddle of water that is around this deep. Okay, so the water is around this deep. This is the water. Now, if I evaporate it, right, what happens is that the particles on the top of the surface of the water, they will gain energy from the surrounding. They will gain energy from the remaining liquid particle. Okay, they will suck up all the energy. Once they got enough energy, what happened? They will break away from the surface. They will break away from the surface and they will evaporate as gas. So what happens? You will realize that there is a cooling effect because the energy have been sucked away. The energy have all been sucked away. But the remaining water particle or water molecule, they are now decreased in energy. If I've decreased in energy, what does that mean? Decrease in speed. This means that the temperature will also decrease, right? Because if I move fast, I'm very hot, right? If I move slowly, I'm very cool, right? So once again, your idea of agitation. What about boiling? Okay, boiling is where bubbles are formed when gas particle escape from the liquid. Okay, so I'm going to give you another analogy. Imagine this is the same puddle of water, okay? Same puddle of water. Now, at the bottom, I on some fire, okay? I on some fire at the bottom, right? So now it start to heat up the bottom, okay? And you realize that all the liquid particle, okay? We have all the liquid particle inside the water. They all gain energy together. They all gain energy together, right? Because I supply external energy. I supply heat. Okay, heat energy is supplied. These particles are all going to absorb the energy and they have a lot of energy. What happen? They're going to just boil away. They're just going to turn into gas. Okay, so I hope that this have helped you to distinguish between the difference of evaporation and boiling. All right. Now, okay, so if this is done, let's go on to the next page. Now, this part over here, I want you to just read by yourself, okay? Not very important. Property of matter and property of particles, okay? Now, diffusion is the last concept I want to cover today. This one is the very important as well. Now, diffusion is something that is commonly tested in WA1 or whatever your school call it, term assessment 1, okay? The one that is happening very soon already, yeah? Now, the process of diffusion is defined as where particles move randomly, okay? Write this down, Okay, now let's explore how they move. Now you can see over here that I have a figure over here to illustrate our understanding. Now, if I have many particles over here, after some time, this particle will redistribute itself to actually follow this arrangement over here. You realize over here, okay, they are very closely packed, but here is an empty space. Here is an empty space, nothing here. After some time, what happens? These particles are going to redistribute themselves into a region whereby they are all equally spaced out. Now, this is what we call the process of diffusion. I always give this example to my students. Now, if I make a cup of Milo, okay, you agree with me, if I make a cup of Milo, below I put the Milo powder, on top I put the hot water, right? After some time, what happened? You realize that the Milo powder is going to just slowly make its way up to the surface, right? Slowly make its way up to the surface. This process is also known as diffusion, right? Where particles of different substance, they redistribute themselves to form a substance of equal distribution. Here is unequal distribution. Some part got more, some part got less. This one is called equal distribution because all part got the same amount. Now, there is this chemistry term I want you to learn. It is called concentration. Now, concentration is defined as the number of particles per unit volume, which means that in one part that I look at, how many particles is there? Then when I look over here, how many particles is there? Then when I look over here, this particular section over here, how many particles is there? So this is defined for me as the term concentration. Okay, so let me erase this one first. Now, this part over here, do you agree with me that there are very high number of particles per unit volume? Because I look at this small area, so many particles. This is what we call high concentration. Okay, what about this part over here? Don't have anything one. This is called low concentration. Okay, so high concentration and low concentration. What do you notice? Particles will always move from a region of higher concentration to a region of lower concentration. It will always move in this way. High concentration, move to low concentration. High concentration, move to low concentration. Okay, so let's write down our definitions over here. Region of high concentration to a region of low concentration. Okay, to fill up any available space. So this is what we call diffusion. Okay, so diffusion is basically this, whereby substances that are very closely packed, they don't like each other, so they want to spread out. They want to spread out, safe distancing from each other. They will actually diffuse out to the parts whereby there are less people. Okay, so imagine I have a crowd over here. Okay, they are going to actually disperse itself so that they can space out. All right, so this is what diffusion is all about. Okay, and for the question, I want you to go back and try the question yourself, because these questions are actually quite simple. Now, I want to cover what is the factor affecting diffusion, okay? Factors are affecting diffusion. Okay, so factors affecting the rate of diffusion, how fast diffusion occur. Sometimes diffusion occur very slowly. You imagine I have a packet of Milo. I pour cold water inside. It takes very long for it to dissolve, am I right? However, if I pour hot water inside, it takes very fast for it to dissolve. Why is that so? Have you ever considered? Because different temperature will affect the rate of diffusion. First factor, once again, is temperature. If I increase the temperature, what does this mean? Diffusion will happen faster, right? Because I supply more energy, these particles all very excited, right? Okay, so they can move very fast. Okay, so the lower the temperature, the slower they move. The higher temperature, the faster they move. Next is mass. Now, if this particle over here very heavy, then I need a lot of energy that I can move, right? If this particle very light, then very fast it can move already, right? So we always consider the mass. If it is high mass, then the rate of diffusion, okay, is going to be very, very low. But on the other hand, if it's a low mass, then the particles move very fast. This means that diffusion is very fast. Okay, so these are the two factors that affect the rate of diffusion. Now, I want you to go back and try out. Okay, so I know that the time is running out already, but I want you to go back and try out the questions. Now, in these questions over here, we actually included some questions for you, okay, to actually take some practice, take some time to go and practice these questions using the concept that we have taught you today about the factors affecting rate of diffusion as well. Okay, so if you are okay with this, okay, let me just go back to the slide. I have just a few more things to share with you first, okay, especially the giveaway as well. Okay, so let me just share with you the Sec 3 roadmap first and why we are doing this. So for Sec 3 student, okay, I want to share with you this quote. Today is the opportunity to build the tomorrow that you want. Okay, so whichever effort that you put in today, tomorrow you will get it as your result as well. Okay, so if today you put in very little effort, of course, tomorrow your returns will be very low. But if you put in a lot of effort today, I promise you the efforts will be repaid in terms of your results. So for Sec 3 student, we are already at this part. January to April, school cover content, topical quiz, practical exam. May to July, we have mid-year assessment, remedial extra lessons, end-of-year revision. And August to October, we have end-of-year preparations, chemistry practical, and end-of-year exam. Now, I'm very excited to announce that we have this program that is up and coming only for students who are very committed and very passionate about this, okay? So this is called the Sec 3 Chemistry Free Tuition Lessons, which will happen weekly, okay? This program is called A Plan to Win, okay? And this plan over here, we have actually crafted for you to achieve your best ever result with very minimum stress. So we know that some of you may be very some of you may have some financial difficulty, or some of you may have some reasons that you are unable to sign up for tuition lesson, and sometimes your school teacher may not be able to deliver the concept of the best of the ability, or you need some extra help on top of your weekly lesson. Then you can actually consider our free classes that we are going to run every day, every week, okay? And the thing about this is that it is not for all students, okay? I want to just declare first that this is not available to all students, but we only accept students who are very committed and very passionate to work with us, all right? So this is a free program, and this is designed to help you ace your Sec 3 and Sec 4 with ease. So this is only available once again for the committed, passionate learner who wants to do well under our guidance. So if you're struggling with chemistry, you need a pair of extra helping hands, you can actually consider our A Plan to Win program for us to actually reach out to you to guide you and handhold you towards acing chemistry. So for students who want to join us, we have already run this program since last year. Some students have actually feedback that the tutor is very patient, okay, and chemistry has gotten very fun to learn, especially for all the concept that we actually teach students, as well as polls and all the questions that we actually address during the sessions. Now, I remember one of my students, they actually are unable to attend the session or unable to go for a school for a long time. We actually do lesson recording and actually send to them to help them to understand those concepts that they find confusing as well. Okay, so if you are interested in this program, we are actually opening up the slot for Sec 3 and Sec 4 students. Sec 3 will be at this timing, Sec 4 will be at this timing. Both will be online, okay? Both will be online. And we are actually going to cap the class size at 15 students to ensure optimum learning, because we only have a few more slots to go before we open a new class. Okay, so if you are interested, please sign up soon for this particular program. So if you are interested with this, you can actually sign up using the QR code over here. And this QR code, okay, will actually give you the registration form to our giveaway, which is the free tuition program as well. Okay, so if you have any question about this program, you can let me know in the chat box, or if not, okay, I can also send to you the QR code and the link as well to this fill up this form as well. And one more thing, okay, for you to have apply this, you are actually required to actually tell us why you are interested in joining us. Okay, so if you want to get a better chance of getting a spot, then you can actually follow us by giving us a feedback form and follow us on Instagram to actually learn more about our programs as well. So you can join us on Instagram and fill out our feedback form over here to actually learn more about us.